Hello, my name's Paul van den Branden and I work for SciMed. Today's video is to show you another example of how the new and novel Collo Probe can be used to fingerprint or to quality control your batches of liquids, pastes, wines and spirits, chemicals, anything that's in either liquid or gel form. Today's example will be a simple illustration, a simple example to give you a feel for what you can do with a Collo Probe. So please follow me into the demo lab and let's go and have a play with this new exciting tool. So here we are in the SciMed laboratory, and we've got a little experimental setup here with our Collo Probe. And as you can see, the Collo Probe is a very simple design, rugged, and currently immersed in some water. I shall just pull it out for a second to explain how the system works. This black area here is where everything happens. The probe emits an electromagnetic field into the liquid or the gel or the suspension, and it will pick up the electromagnetic response from the sample, and that is a signal we're going to be processing. So very simple, very rugged, stainless steel and a robust polymer. And essentially what will be required is for this section of the probe to be immersed in the sample we're looking to analyze. And to illustrate what the probe can do and how sensitive it is, we've decided to pick a very simple example of a range of black fizzy drinks. And we have got here 5 different versions of black fizzy drinks that we're all very familiar with. And what I'm going to do is measure these fizzy drinks on a probe to see what signal difference we get. Each one would suggest that are different from the other, and that is what we're going to find out. Now, the parameters that we're going to be directly measuring with a probe are what's called the Collo Permitivity, which will be on the left-hand side, and on the right-hand side, we're going to be measuring the Collo ion viscosity. Now, the permittivity generally is very sensitive to the presence of oils and fats, which in the case of these drinks are not present, therefore we're not expecting much signal change at all across these samples. Whereas the ion viscosity will be detecting changes in ionic charges and possibly will respond a lot more in this particular case. So we've got 2 ways of measuring the materials, two different data points, different data sets, and depending on the samples you've got, one will be better than the other. So here we go. I shall take our first sample, which is in this glass, and that is what we would define as the original drink. Okay, so take the water out, immerse our first drink, and start acquiring data. So as I explained, the left graph gives us a Collo permittivity, the right graph gives us a Collo ion viscosity, and we can see a significant step change between water and this original drink. So clearly we would expect that, very different, and the Collo Probe is detecting it. So that's the first set of sample signal we've got. I shall now take a sample of the 0 version of the drink, take out the original, and as you can see, I'm not even wiping the sensor straight into the other one, and we can now see what we get. And immediately there is a step change, so the 0 version of this drink is showing a difference in signal. And that's what we were hoping for, and this is what's being demonstrated here. You can see it's instant, it just takes a few seconds, and realistically, in most applications, that's enough to say, well, this drink is different. Now, if this was a batch-to-batch check, we would be concerned, because it would show that this batch is different in the signal that's responding, therefore, we need to do something to get it right. If you're looking at a counterfeit product, you can see straight away, well, that's giving a different signal to the original drink, it is a counterfeit, and that's what we would want. This is not what we're suggesting here with these samples, but these are simple examples of what this can be used for and is already used for. I shall now bring the dyed version, which we would hope is not the same as the 0 version, as it's being branded differently. And when we put our Collo Probe inside, let's see what it tells us. And after a few seconds, we can also see that there is a change between dyed and 0, but also still a difference compared to the original. So far, so good. The Collo Probe is showing us the differences between these different varieties of drinks. Now what we're going to do is take a sample of what we've called as pop, which is simply a different brand of the same drink. And this is what I would call pop original, and we shall see what that tells us. We'll give it a few seconds. Let's see what happens. And as expected, we once again get a differencing signal on the ion viscosity. We can see from the data that the Collo permittivity has not changed. That was expected. But what we hope for has happened is that the ion viscosity has changed again and providing a fourth set of data different to the other three. So this different branded drinks has got something different compared to the other brand. And our final sample will be what we call Pop Max, which is a variant of Pop. And I shall make my final sample transition. And here we go, Pop Max. And as you can see, once again, we're getting a fifth signal for ion viscosity, which is fantastic because it tells us two things. These drinks are generally different, certainly as far as the Collo Probe is sensing it. And you would expect them to be different. This is neither an endorsement or either of the versions, but what we were hoping was to see that these were different drinks. So this is it. I shall now finish by just putting our water baseline back in as we wrap up. Two other sets of data that can be generated using the Collo Probe and the graphs from the software are what's called the 8 senses diagram, which is like a spider diagram and presents the data in a different format. You can see that diagram shows, again, the variety between all these various samples. And then the last set of data we can generate is a 2D plot of the Collo permittivity versus a Collo ion viscosity. And again, we can see the scatter between these various materials. So hopefully this video has been a good way to illustrate to you what the Collo Probe can do. Clearly this can be used for a whole variety of samples, and we'll just put a few examples here from all sorts of milks, dairy products, and cosmetics, toiletries, chemicals, liquid medications. It can be used for a whole raft of applications, even things like paint and other chemicals that might need some form of quality control or simply fingerprinting. Now, we would love to try the Collo Probe on your samples, on your applications. So if you look at the details at the bottom of the screen, you will see all our contact details. Please do get in touch. We can bring this Collo Probe into your lab, into your process, and give it a go. Why not contact us? We really hope to hear back from you. And thank you very much for watching this video.